Today we are going to discuss this problem. So this is the easy version. Its rating is 1800, and it has a hard version by simply increase the problem size here, right? Currently it's 300. It can increase to 10,000, right? As always, we are going to introduce this problem by explaining the example here. So what do we got? So in the input, we are going to have two numbers, right? The first number is the size of the array here, right? So we are going to move this array here. 2 minus 2, 3, 1, 2, right? And here is their index 1, 2, 3, 4, 5, right? And 4 here is the number of number pairs following, right? And the number pairs indicates the index for this array, right? So for this number pair, it starts from index 1 to end at index 3, right? And for this number pair, it starts at index 4 and at index 5. This guy starts at index 2 and at index 5, right? Etc. And we are going to have one kind of operation here. So that is, we can choose a number pair. For example, we choose this guy, and we are able to decrease all those numbers inside this number pair by 1. For example, we can decrease if we choose this number pair, we can decrease the first index by 1, uh, from which we can get 1. And for this number, we can get a minus 3. For this number, we can get 2, right? And we can choose another number pair. For example, we choose this guy, right? So after we choosing this guy, we can decrease this guy by 1, decrease this guy by 1, and decrease this guy by 1. And now we get 5 new numbers, right? And we are going to choose any number of number pairs. And we need to make sure that the maximum differences, the maximum difference between the numbers is maximal, right? So in this case, we're going to get 6 as the difference, right? So the maximum number in this array is 2, and the lowest number is minus 4. The difference is 6, so we output 6 here. So in order to achieve the maximal difference, we need to choose 2 number pairs. The first one and the fourth one, right? These 2. So how can we find out the maximal difference, right? And how can we find out the way we can create the maximal distance by choosing these number pairs, right? So we are going to achieve this by this process, right? So for each index, we are going to do these 2 calculations, right? The first one is that we ask the question, how can this number get to the lowest it can be, right? So for example, um, for this number 2, the lowest it can get is 0, right? By choosing this guy and this guy, right? How about this number? So this number, the lowest it can get is -5, right? By choosing this guy, and this guy, right? So what is the second step mean? So it means that when this number get to the lowest by choosing these two number pairs, the maximum number in this array is 2, right? Because previously the biggest number is 3, but by choosing these two number pairs, 3 already decreased to 1, so 3 is not the largest anymore, but 2 is the largest, right? So after we get the lowest number, which is 0 here, and the largest number is 2. So the maximum difference we can get for index 1 is 2. So we save 2 into the answer, right? And thus we can repeat this process for the rest of the index as well. So for example, for index 2, the lowest it can get is 5, -5, right? By choosing these three number pairs. And the maximum number in the array when we choose these three number pairs is 1, right? Because this guy is already decreased to 0, and this guy decreased to 1 because of this number pair. So the largest is 1, the smallest is -5. So the difference is 6. 6 is bigger than 2. So we can update the answer to 2, right? So in this case, we are going to repeat this process for the rest of the array. If we already did that, we can find out that the maximum difference is 6. So we can choose, we can output 3 and output 1, 3, 4 here. That's okay, right? Even it is different the test output, that's okay. We only need to output one viable solution, right? So I guess that's it. So how do we find out the lowest number we can get for each number? So that is the question here. So I guess when we saw some number pairs, the first instinct is that we want to order. We want to sort these numbers, right? In the way that sort by its location for these points. For example, this guy is the first one. This guy is the second. This guy is third. This guy is the fourth. This guy is the fifth. This guy is sixth, seventh, eighth. Right? So in this way, we sort these endpoints by their location, right? And when we iterate from index 1, we can push these two left points into a stack. Now we have two left points in the stack, right? So the lowest this number can get is 0 by -2, right? And we move to the second index, and we find a new left point and push it into the stack, right? So it's 3 now. So we have 3 number pairs now. So the lowest number it can get is -5 by decrease -2 by 3, right? And let's move further right. And now we don't have any left points here. So the lowest it can get is still by -3, right? So we get 0 here, right? And now we are going to look for the right points, right? So we find the 2 right points here, and we decrease the stack by 1, by 2. Then we get 1, right? We still have 1 number pairs in the stack, right? And we get to index 4 here, and we find out there is a left point, so we increase the stack by 1. Then we get 2, right? So the lowest it can get is -1, right? By decreasing 2. And we move further right, and we don't find any left points, so the lowest it can get is 2, right? So lowest it can get is 0 by decrease this number by 2, right? So that's it. That's how we get the lowest. And when we already get the lowest, we already know which we will know which number pairs are we using, right? By using the stack we described before. And we can just iterate these numbers and iterate those number pairs in the stack. And in this way, we can get the maximal for the rest of the array, right? So that's the way of solving the easy version of this problem. So the complexity of the second step is n multiplied by n, right? Because we need to iterate each of the numbers in the array, and we need to iterate each of the number pairs. And we even got a complexity outside of this loop, right? So the overall complexity is n multiply by n multiply by m, right? So I guess that's all for the easy version, right? That is acceptable because n and m is very small in the easy version, right? But what about the hard version, right? Let's find out the hard version here. The hard version problem size is 10,000, right? So how do we solve this? So we need to simplify this complexity. This complexity is way too big, right? So we can uh, do it with a segment tree, right? And we can uh, complete this step by just O log, excuse me, by O log n, right? So how do we achieve that? By using segment tree here. So when we find out the lowest uh, we also know what are the number pairs are chosen, right? So um, we are going to maintain a segment tree. Uh, let's say this segment tree supports two operations. One is to query the uh, maximal number in a array, right? They're going to be an array. And the second operation is that update from start point and a end point and the value. It can be +1 or -1, right? Let's say we already have this data structure supports these two operations, right? How do we solve this problem? So uh, as previously said, right? When we iterate to this number, we can push these two left points into a stack, right? And when we push this guy into the stack, we need to update the array, right? We will update from the first from the left point to the end point, and decrease these numbers by -1, by decrease it by 1, right? So that in this segment tree we still hold all of the numbers values, right? And when we push another left number into this stash, we are going to also update the data structure so that we can minus all of the numbers between these 2 points by -1, right? And after we did these two operations, we are going to query the maximum number in this data structure, right? And we're going to use that maximum number to calculate the maximum difference, right? So the key is to calculate the maximum number, right? And when we iterate to index 2, we find out another left point. So we update the data structure again. And when we iterate to the third data point, we find a right point, right? That is where we update the data structure again to um, step back from previous operations by update these numbers by increasing them by 1, right? So in this way, the data structure can help us to find the maximum array um, after we do the operations, right? So the key question now is how to construct such a data structure that can support these two operations. So one is query maximum, the other is to update, to range update values, right? So I'm not sure I want to explain the implementation of the data structure here. So let's do some research on this data structure, right? So let's search range query segment tree, range updates segment tree, and another keyword is maximum, right? So this implementation is just support query maximal and support update one item, but we need it to support update a range of numbers, so it's not good enough. Here we go, lazy propagation. Yeah, what if there are updates on a range of array index, right? So you can check out this part. So it's quite an advanced topic, so I won't dive deep into this topic here because this problem's rating is already 2100. So for my current tutorials, I'll concentrate on the problems that are around 1800 here. So I guess that's all for today. Thank you for watching. Goodbye.